Supernovae stand as the universe's most intense explosions, bright enough to eclipse entire galaxies. Their magnitude is hard for us to grasp. Imagine our sun transforming into a supernova. This event would feel like enduring the blast of a nuclear explosion, non-stop, every moment, for weeks. These astronomical phenomena aren't merely agents of destruction, they're also creators. Supernovae are essential in the cosmic cycle, crafting the elements that are the building blocks of life. Yet, their colossal energy output can also cleanse vast areas of galaxies, rendering them lifeless. What if such a mind-boggling event were to happen near Earth? Let's delve into this intriguing but scary possibility. In general, there are two paths to a supernova. The first is when a giant star's core collapses into itself. The second, less frequent path occurs when a white dwarf star accumulates enough mass to set off a massive nuclear fusion explosion. No matter how it happens, the outcome is a monumental blast signaling the closure of one cosmic era and the dawn of another. When we think of explosions here on Earth, we usually picture something quick and definitive. Yet, trying to compare that to the magnitude and lasting impact of a supernova is like comparing a candle to a wildfire. The incredible power and the lasting effects they imprint on the universe invite us to broaden our perspectives on our existence and the universe at large. As we explore further, remember that supernovae serve a dual purpose. They are both creators and destroyers, highlighting the intricate balance of the cosmic order. Rather than envisioning a supernova as a simple explosion, picture it as a combination of a volcanic eruption and a tsunami. It starts off as a captivating, vibrant sphere of hot, expanding gas, forming a breathtaking nebula that illuminates the cosmos for around a month. Yet, the spectacle is far from over. The aftermath of a supernova goes beyond any earthly event in both drama and scope. This heated, menacing gas doesn't just fade away. It propels itself outwards at astonishing speeds of 10,000 kilometers per second, cutting through the almost empty vacuum of space with immense force. It engulfs the sparse cosmic gas it encounters, creating an ever-expanding gas front. This front travels vast distances, spanning tens of thousands of years and stretching across up to dozens of light years, before it eventually starts to cool down, slowly releasing its gathered materials back into the galaxy. This phenomenon serves as a stark reminder of the universe's vibrant and ever-evolving nature. The aftermath of a supernova marks not just the demise of a star but plays an integral role in the cosmic cycle of renewal. These stellar remnants are instrumental in the birth of new stars and planets, some of which may be capable of hosting life. Delving into this topic unveils a captivating connection between us and these celestial events. The very elements constituting our planet and our bodies were forged in the cores of stars, then scattered across the cosmos by the force of supernovae. Now, let's tackle a thought-provoking question: what if we were to experience the effects of a supernova firsthand? The impact such an event would have on Earth greatly depends on its distance from us. Stage 1: thousands of light years away. Humanity has witnessed numerous supernovae throughout history, though all have occurred at distances of thousands of light years. These events appeared as new, luminous stars, some so bright they rivaled the moon, lighting up our night sky for weeks before gradually dimming. At such significant distances, these supernovae are essentially cosmic fireworks displays, magnificent and captivating, yet too far away to pose any real threat to us. Stage 2: 300 light years away. When a supernova explodes a mere 300 light years away, the situation begins to shift. Such events are predicted to happen in our galactic neighborhood every few million years. This proximity would bathe the night sky in an otherworldly glow reminiscent of perpetual twilight, casting a beauty that's as unsettling as it is enchanting. At this distance, Earth remains shielded from any direct physical threats posed by the supernova. It's still too far to inflict any damage on our planet's surface. Yet, it's close enough for us to feel the softer echoes of this cosmic upheaval. It's like sensing the gentle tremors from a distant, monumental event, too mild to wreak havoc, but significant enough to leave a mark. This might manifest as minor alterations in Earth's atmospheric chemistry or slight shifts in the levels of cosmic radiation that penetrate our planet. While not directly harmful, these changes serve as a reminder of how deeply interconnected we are with the broader cosmos. Supporting this notion, geological findings over the past 10 million years reveal that Earth has indeed felt the touch of supernovae from similar distances. Traces of radioactive iron isotopes discovered in the depths of the ocean within ancient rocks and sediment act as celestial clues. They tell a story of past encounters with the fallout from distant supernovae, illustrating the subtle yet undeniable impact these stellar events can have on our planet. These cosmic explosions have significantly shaped the region of space that envelopes our solar system, giving rise to what's known as the local bubble. This enormous void in the interstellar medium, spanning roughly 1,000 light-years, has been carved out by the potent blasts of supernovae. These forces have swept away much of the interstellar gas and dust, crafting a spacious cavity. The edges of this bubble are defined by thicker, irregular masses of gas, which now serve as the birthplaces for new stars. This fascinating process underscores the dynamic, ever-evolving character of the universe, showcasing supernovae as pivotal agents of both destruction and creation within the galaxy. Stage 3, 150 light-years away. Approaching a supernova event within a much tighter radius, say about 150 light-years from us, the narrative shifts dramatically. In such proximity, the gentle nudges we might have felt from distant supernovae become potent forces capable of profound effects on Earth and all its life forms. The impacts of a supernova at this range could profoundly affect our planet's atmosphere, climate, and the very essence of biological existence. Venturing into this closer examination, we transition from the marvel of cosmic spectacles to a deeper awareness of our fragility within the expansive universe. The awe-inspiring power of these celestial events is matched by their potential to disrupt the delicate environmental and biological equilibrium of our planet. This contemplation not only highlights the grandeur of the cosmos but also underscores the intricate balance that sustains life on Earth, reminding us of our place within the vast, cosmic tapestry. The magnetic forces of stars are incredibly potent, and this power does not simply disappear with the star's demise. When a star explodes as a supernova, it releases a torrent of stellar debris, carrying with it immense magnetic energy that intertwines with the outward rushing shockwave. Within this electrified cloud, conditions reminiscent of a giant particle accelerator come to life, hurling charged particles like protons, nuclei, and electrons to astonishing speeds. This generates an expanding nebula, radiating lethal doses of energy in every direction, long after the initial explosion's glow has faded. If such a supernova were to explode near enough to our solar system, Earth could find itself in the path of these cosmic rays for millennia. Our planet's atmosphere and ozone layer do offer a shield against the harshest elements of space, protecting us to some extent. Nevertheless, a surge in radiation from a close supernova would have dire repercussions. It could potentially cause an increase in cancer rates and genetic mutations among Earth's life forms. Though not necessarily culminating in a mass extinction, the effects on health and the environment would be deep and widespread. For human endeavors in space, the scenario becomes grim. The intensified radiation from supernova-borne cosmic rays would make space travel within our solar system perilously dangerous, if not entirely unfeasible. Astronauts, lacking the natural protection of Earth's atmosphere, would face extreme risks from the increased radiation, turning extended space voyages into perilous endeavors. This situation underscores a universe filled with marvels and beauty, yet also harbors risks that could profoundly influence terrestrial life and the future of human space exploration. A supernova exploding relatively near Earth could bring about significant challenges for humanity, potentially anchoring us to our planet for centuries or even millennia. The closer such an explosive event occurs to us, the more dire the potential consequences become. Stage 4, closer than 100 light-years. Encountering a supernova within 100 light-years places us in a realm of uncertainty regarding its effects on Earth. At this range, it's expected that our planet's climate would experience profound disturbances, the specifics of which are challenging to predict but are universally agreed to be severe. Experiencing a supernova from this proximity involves a sequence of harmful stages, each progressively worsening the condition of Earth's environment. 1. High-energy photon barrage ***. Initially, the supernova bombards us with high-energy photons. These photons, traveling at light speed, serve as the vanguard of the supernova's effects, hitting the Earth's atmosphere and triggering environmental changes. 2. Radiation from the radioactive tsunami ***. After the high-energy photons, Earth would face long-lasting intense radiation from the supernova's ejected radioactive materials. Such extended radiation exposure poses a serious risk to the ozone layer's health, crucial for protecting life from the sun's harmful ultraviolet rays. The ozone layer acts as our planet's safeguard, effectively absorbing and neutralizing a significant portion of the sun's harmful ultraviolet radiation. This is achieved through a sophisticated chemical process where ozone, O3, molecules are split into diatomic oxygen, O2, and a single oxygen atom, which later rejoin to create new ozone molecules. However, a surge of radiation from a supernova in close proximity could gravely impair this protective barrier, reducing its ability to protect Earth from ultraviolet light. Such deterioration could lead to a spike in skin cancer cases and other health problems in living beings, along with wider ecological disturbances. Faced with this scenario, humanity would encounter a twofold challenge: addressing the immediate health and environmental fallout from the surge in radiation, and confronting the enduring effects of an atmosphere in distress. This situation would also complicate space exploration efforts, demanding advancements in technology and safety measures to safeguard astronauts against the unforgiving conditions of outer space. The deleterious impact of supernova radiation on Earth's atmospheric chemistry would exacerbate an already critical situation. Such radiation inflicts damage not only directly on living organisms but also triggers a cascade of chemical reactions that weaken Earth's natural protective mechanisms. One significant reaction involves the disintegration of nitrogen molecules in the atmosphere. Under normal circumstances, the cycle of ozone regeneration depends on a specific balance of oxygen atoms and molecules. But the intense radiation from a supernova can dismantle nitrogen molecules, which then proceed to absorb the free oxygen atoms. This disrupts the essential equilibrium necessary for ozone creation, precipitating a swift decline in this indispensable layer. Bereft of this vital protection, Earth's surface would be exposed to intense levels of ultraviolet radiation from the sun, significantly raising the incidence of cancer and making daylight exposure extremely hazardous. The repercussions of increased ultraviolet radiation go well beyond the health of humans. The marine ecosystem, particularly plankton near the ocean's surface, would suffer immensely. Plankton are pivotal to the marine food web, and their significant reduction or elimination could trigger a catastrophic collapse in ocean biodiversity, potentially leading to widespread extinction events that would upset ecosystems across the planet. Moreover, the effects of supernova radiation introduce further complications. By ionizing atmospheric gases, the radiation effectively removes electrons from atoms, rendering them positively charged. These ionized particles can act as cores around which water vapor condenses, possibly leading to the development of extensive, dense cloud cover around the globe. In extreme cases, this cloud cover could reflect substantial amounts of sunlight away from Earth, drastically reducing global temperatures and perhaps initiating an ice age. There is historical evidence to suggest that supernovae have previously impacted Earth's climate and the course of biological evolution. For example, it is theorized that a supernova occurring around 2.5 million years ago may have been a catalyst for the ice age that occurred during that era. Additionally, there is speculation that a supernova approximately 60 light-years away might have played a significant role in the Devonian mass extinction around 350 million years ago. These instances highlight the significant, though indirect, influence that supernovae can exert on our planet, demonstrating a deep-seated link between events in the cosmos and life on Earth that extends across the eons. The devastating consequences of a nearby supernova go beyond atmospheric and climate disruption. The event's radiation could significantly impact Earth's electromagnetic landscape, unleashing electrons that spark massive electrical disturbances. Imagine electric avalanches giving rise to global lightning storms of a magnitude not seen in millions of years, fierce enough to spark wildfires on an unprecedented scale. These fires, fueled by relentless lightning, could obliterate vast tracts of forest and farmland, lay waste to cities, and cripple electrical infrastructures, exacerbating the dire effects of a compromised ozone layer that fails to shield us from deadly radiation. Such catastrophic events would test the limits of modern civilization's resilience. While natural ecosystems may have rebounded from past supernova impacts over thousands or even millions of years, the immediate fallout for human society could be catastrophic. We could see widespread food shortages as agricultural systems fail, causing prices to surge and possibly sparking conflicts as nations struggle to maintain stability in the face of escalating chaos. The repercussions of a supernova this close could resonate for centuries or millennia, potentially claiming millions or billions of lives. However, despite the grim outlook, there remains a beacon of hope for humanity. Our societal resilience, our unwavering spirit of innovation and adaptability in the face of hardship, suggests that we could withstand, recover, and eventually thrive again. The journey to rebuild in the wake of such a cosmic calamity would be arduous, yet it also offers a chance for regeneration and a testament to the enduring strength of the human spirit. Stage 5, closer than 25 light-years. When Earth finds itself within 25 light-years of a supernova, it crosses into what's ominously termed the kill zone, a distance where a mass extinction event becomes nearly certain. The fallout here is exponentially worse than from more distant supernovae. About half of the ozone layer would be destroyed, plunging the climate into chaos unmatched in human history. Ecosystems would crumble under the onslaught of intense radiation, while uncontrolled wildfires would sweep across the globe, leaving destruction in their wake. The rapidity and ferocity of these events would leave little room for survival, with only a slim chance for those sheltered in well-stocked bunkers. The Earth that emerges afterward would be a desolate, inhospitable landscape, with human survival hanging by a thread. Final stage, closer than 4 light-years. As we move closer to a hypothetical supernova within 4 light-years, such as one occurring at the distance of Alpha Centauri, the scenario becomes catastrophic. This proximity would make the supernova appear as bright as our Sun, casting eerie double shadows and offering a brief, surreal spectacle before leading to cataclysm. The resultant extreme heating would make Earth's surface intolerably hot, sterilizing it of life. The oceans, which might provide a haven under less severe circumstances, would become death zones, unable to shield life from the lethal radiation onslaught, annihilating any organisms exposed to direct sunlight. Largest extinction event in history. Such proximity to a supernova would lead to the most significant extinction event in Earth's history, reducing life to mere remnants in the deep sea and some underground species. The challenge of recovering from such devastation would be unprecedented, necessitating a near-complete restart of the evolutionary process from these few survivors. This scenario underscores the fragility of life in the face of the cosmos's immense forces, highlighting a stark reminder of our place within the universe's vast expanse. Conclusion: how much concern is justified? Despite the daunting scenarios we've discussed, there's little reason for immediate worry. Our cosmic neighborhood within a 1,000 light-year radius houses only a handful of stars with the potential to go supernova, and none pose a direct threat to us anytime soon. Moreover, any stars on the brink of such a transformation are likely millions of years away from their explosive finale. Looking ahead, the unpredictability of cosmic movements means we can't be entirely sure what the future holds. However, there's optimism that humanity will have progressed enough to either move away from or mitigate the effects of a supernova should we ever face such a threat. So, for the time being, there's no need for sleepless nights. The night sky should serve as a source of beauty and/or rather than a cause for alarm. The sheer expanse of space and the infrequency of supernovae in our cosmic vicinity provide a significant buffer against these stellar explosions. Allow yourself to be captivated by the stars, feeling secure in the vast, majestic universe that, despite its capacity for destruction, remains the birthplace of all we know and cherish. What do you think about these deep cosmic questions? Are these theories merely flights of fancy, or do they provide real insights into the universe's mysteries? Share your thoughts and engage in the dialogue about the boundless possibilities waiting just beyond the edge of our known universe.